So here we have another pyramid and another cone, and we've been working with volume of these types of shapes. But we're going to do something a little bit different. This time we already have the volumes. We have the volume of 240 for the pyramid, we've got the 1527 for the cone. But what we're going to do is we're going to try and find some missing measurements. For example, here we are looking for the actual height of the pyramid, and here we're actually looking for the diameter of the actual cone. So let's just start with the pyramid. Now let's just start with the expression. Volume for a pyramid, which we've been using before, is 1/3, and then it's just length times width times height. Now really the only thing we're missing is the height. We have the length, we have the width, and there's different ways people will solve something like this. Some people, what they like to do is put in the numbers. So for example, the volume is 240, and this is equal to 1/3. The length we can say is 12, the width we can say is 5, and then we times that by the height. Well, some people, what they would do is they would actually multiply this out. So if we do that, that'd be 240 is equal to, well, 5 times 12 is 60. 60 divided by 3, or times 1/3, would be 20. So that'd be 20 times the h. Well, now we can use reverse order of operations. We've got to isolate the h, so we have to divide by 20 on this side. We'll divide by 20 on that side. That cancels out. And then 20 divided into 240, well, that goes 12 times. So that would be then our height. Height would be then equal to 12 yards in this case. So that's one way sometimes people do. They just put the numbers in and like to work with it that way. Another way people would like to do it, and I'm just going to shrink this down, give ourselves a little bit more room over here. Okay. Another way people do is more of an algebraic type way. So some people, what they would do is they would do more algebraically, where they say volume is 1/3 length times width times height. And what they'll do is they'll actually solve for h and see if they can get that by itself. So to do that, you'd want to use reverse order of operations. So we'd have to times 3 on both sides. So we 3 times the volume on this side, and that would then cancel off that. And then since we're multiplying by the length and the width, we would want to divide by the length and the width on both sides. So divide by the length times the width, divided by the length times the width. Those would all cancel, and we're left with height is 3 times the volume divided by the length times the width. And if you do the same calculation, you'll still get 12. So most people would probably just put in the numbers and then just try and solve for the missing numbers. But some people like to look at it more algebraically and would do something like this. But for starting out, just doing the numbers and getting the 12 that way is perfectly fine. Okay. All right. Well, let's do something similar for the cone. So the formula for finding the volume of a cone, volume is going to be equal to 1/3 times the pi r squared times the height of the actual cone itself. Okay, so again, we've got a bunch of the numbers. The radius is what we would be looking for in this case, so we can find the diameter, but we have everything else that we need. So the volume is 1527, and that is equal to 1/3 times pi, or 3.14, times the radius squared, times the height or length, which is 15. So again, some people, what they would do is they would just multiply all the numbers they have together. Some people would divide them separately. It doesn't really matter. But let's try just multiplying the 1/3 times pi times 15 to try and do a little bit differently. So we have the 1527. If we multiply the pi, the 1/3, and the 15 together, we get about 15.7. So that's those two and that guy multiplied together gives you 15.7, and then that's multiplying times r squared. So now we can just divide by 15.7 on both sides to isolate the r squared. That would cancel out. And if we do 1527 divided by 15.7, we get about 97.3. and this is going to be equal to r squared. Not r, but r squared. So what we need to do to find r is we need to take the square root of this. So we need to square root this, so we need to square root this. So you need to take the square root of 97.3, which will give you about 9.9. And that would be the radius of the actual circular part. So of course the diameter is twice the radius, so we just have to double that. And then your diameter would be twice this amount, which would then give you about 19.8 kilometers for the diameter. So this was just using the same type of calculations and stuff that we've done before, but sometimes it's nice to try and actually work backwards instead of just always forwards, and sometimes you won't have the values that you want at the beginning. You'll have the volumes, you'll have the endpoint, and being able to try and go backwards really helps the understanding of how it actually works and gives you a better, deeper knowledge of how the formulas actually work, the relations, the functions actually work, and how things can connect together, and you can practice a little bit of your algebra and your reverse order of operations.